Hey guys, hello everyone, good morning. All right, let's get started. Okay, so I think this is going to be our fifth lecture, right? I'm not exactly sure is it fifth or is it sixth? Okay, so we are
Fifth
going to
class
have
only. It
fifth
is
only,
fifth.
right?
Yeah.
Okay, thank you. So I think we are going to have 2 weeks of NLP classes, right? Which is approximately around 10 to 11 lectures. Over here, until now, we have been focusing on theory. Starting from today, we'll be focusing a little on coding side. So we'll see some examples through which we can create codes, and using those, we'll try to understand NLP better. Okay. So I'll quickly recap on whatever we have seen until now. And after that, we'll get started with the coding aspect. Right. So just give me a moment. I'm just sharing my screen. Okay. Let me share a note tab. Okay, I hope everyone is able to see the screen. Let's start. So, if you remember, in the last class, we started discussing about various ways in which we can represent the data, right? So, we had discussed about the document term matrix. We had discussed about what are some of the advantages of using it and majorly what are the limitations of it. Okay. So when we discussed about the limitations, we also discussed about what are some of the solutions that we can apply to ensure that we can handle them. We discussed 4 5 approaches through which we can handle the order issues. Okay. But still it's not foolproof and we need something better. Okay. After that, we had discussed multiple keywords and also discussed regarding the distances, right? So we had discussed about edit distance, we had discussed about phonetic distances, right? Okay. And based on this, we said like we can identify if the words will be similar or not, right? And even this will help you in spelling correction, it will help you in translating things. And that's one of the ways that you can use distances. Okay, so going forward in today's lecture, we'll start with the coding part. We'll see examples of how we can perform sentiment analysis. Okay, I'll just introduce the problem. So sentiment analyzer is a very common problem in NLP. Over here, we look at a text data. Like for example, let's say you have tweet. The tweet is he is not well. Another is he is very happy. There are two tweets, and over here, if you see, the first tweet is kind of negative sentiment, right? You can understand it, it's kind of not giving you a positive vibe. This is giving a positive vibe, and this is why it's positive. Okay, but example, if there is another sentence which is like or let's write another thing. Mm, let's say there is a shop. If you think about this sentence, there is a shop. It's not carrying, I would say, like too much positiveness and neither too much negativeness, right? It looks to be a neutral tweet. Okay, like mixture of positive and negative, or I would say neither positive, neither negative. You really can't say exactly what you want to classify, right? There's a shop doesn't have any significant essence to it. Okay. And that is what we are going to solve using machine learning. Okay. So we'll see a bunch of tweets and using different approaches, we'll try to understand if the tweet, the first tweet, second tweet, and so on, are they positive, are they negative? Okay, and we'll see like if we can convert them to neutral as well. For now, we'll keep it binary only. So we'll try to convert them into positive and negative. But going forward, once we learn some more advanced things, we can also convert them to neutral as well. Okay, so let's start. Let me share the notebook. Okay, just give me a second. My screen is stuck. All right, it's fine. Let me share the full app. Okay, so I wanted to show you one article. So you can go through this article. Let me just share it in the chat as well. I'll just give you a small walkthrough before we go into the code. So in this article, basically they have used one library called as text blob. Okay, so text blob is a specific library which is specifically used for computing sentiments. Okay, over here, this is specifically with NLP. You can install text blob, and after that, we'll see some example. Like once you import text blob, you have a text, and you can apply the text blob function on top of that text. Now in this block is where it will contain multiple properties. Okay. For example, it will contain something called as polarity. It will contain something called as subjectivity. And based on this two things, which is polarity and subjectivity, it will identify whether the text is positive, negative, or neutral. Okay. Over here, we'll see an example and we'll try to understand how does that happen. Okay. So if you see over here, now that we have a text blob object, which is nothing but this output, we can use the sentiment property to get the sentiment. Okay. So below this, you'll see like they're using sentiment, blob.sentiment to understand what is the sentiment. Okay. After that, the sentiment property returns a tuple containing the polarity and subjectivity. So as I said, this library is based on polarity and subjectivity. We'll discuss what is polarity, what is subjectivity just in a few minutes. And based on polarity and subjectivity, it will classify whether it's positive or negative. Okay. The polarity is the float value in the range -1 to 1, where -1 represents negative sentiment, 0 represents neutral, and 1 represents positive sentiment. Okay. So this is straightforward. You check polarity, you check the more towards, if the value is more towards one side, then it's going to be a positive sentiment. If it's towards -1 side, then it's going to be a negative sentiment. Second thing, the subjectivity is a float value in the range 0 to 1, where 0 represents uh, objective text and 1 represents highly subjective text. Okay, so this is something which is based on how you define English. For example, 0 represents objective, right? Objective text is something which doesn't have a lot of meaning. For example, very simple words like, uh, you know, he's standing there. Okay. If I say he's standing there, it doesn't have any context to it. It just says that, hey, the person is standing over there. But if I make it like, hey, he is standing there besides a car in Ahmedabad. Okay. Now I'm adding much more information to it, right? And this is what is the difference between objective and subjective. Objective text will be bland, will be simple. It won't have a lot of information. Subjective text will have many special informations like Ahmedabad, like car, right? It won't have simple words. Okay. Just one more example. Let's say you have another sentence in which you are saying, um, there is a meeting. Okay. There is a meeting, which is completely objective. Okay. But if you say there is a director level meeting happening in the auditorium of your college, or maybe in the auditorium of let's say of HDFC Bank, right? So this is very subjective because here you are giving more information, right? You are being more specific. And that is what is the difference between objective and subjective. We don't really have to figure out how much objective or subjective it is. The text block library will do for us. All we'll do is we'll check which sentences are, like how much subjective. Okay. And based on that, it will try to understand the sentiment. Ideally, it gives you the sentiment. Over here, as I said, it focuses on two aspects, polarity and subjectivity, to understand what will be the sentiment. Okay. So we'll see examples and then we'll understand this better. Okay, so if I print the sentiment, as I said, you will get two outputs, one for polarity, one for subjectivity, right? You can see polarity is one, which means it's tending towards more of positivity, right? For example, as we saw above, that polarity of one represents a positive sentiment. Okay, so it's tending towards a positive sentiment, which is given by your polarity, and the subjectivity is 0.75. So it's tending again towards your subjective text, right? It seems to have some information present. Okay, this is the first thing. If you look at the sentence is, this is a great tutorial on sentiment analysis, right? So this sounds like a positive sentence because this is a great is having some, great is like a positive word. Okay, so it seems to have positive sentiment attached to it. Second thing, regarding subjectivity, so since it's right, this is a great tutorial on sentiment analysis, right? This information is making it subjective. Had this not been present, for example, if the sentence was, this is a great tutorial, then it becomes a objective statement, right? Because then you're not adding too much information in, right? And that is what is a little difference. If you add few more detail regarding the sentence, it will become more subjective. Right now it's simple, like you have not added too much detail. Only one thing which is present is, it's a great tutorial on sentiment analysis. Like this is one thing which is making it subjective, and that is why you see the subjectivity is around 0.75. It's not fully one because you can still add few more information. Okay, cool. Okay, so now let's see how do we want to conclude this. So now we can get
Yeah.
the
Can
polarity and
we work through
subjectivity
subjective
to
and
get
fact?
the different aspects of text. So if you see, the polarity is 1 and the subjectivity is 0.75, right? Which is just saying you that, hey, this is highly, oh, is someone unmuted?
Can we go through subjectivity once more? It actually just went a bit fast.
Uh, Subjectivity? Sure. So subjectivity depends on the context, right? Like how much information are you providing and how specific you are. If I write, this is a great tutorial, then you're not adding any specific detail. You're just saying, hey, it's a great tutorial, which is like objective statement. But if I say it's a great tutorial on sentiment analysis, I'm being more specific. I'm adding more details and it's subjective. Okay. Because you are giving more details regarding the subject, which is sentiment analysis. You are trying to, whenever you try to give more detail, it tends towards subjective analysis. Okay, similarly if I say like, uh, okay, let me write. If I say that there is a holiday, this is again objective, right? But if I say there is a national holiday in India, then this is subjective because we have added many more details like national, India, right? Which makes it highly subjective. Okay.
Yeah, thank you.
Yeah. Okay. So in this, we'll repeat the same thing, but instead of taking only one sentence, we'll take few more lines attached to it. Like we are taking the entire document. So here, the entire document contains, this is a great tutorial on sentiment analysis, which is the first sentence. I really enjoyed it and learned a lot. Okay. So now we have taken the entire document. Okay. So over here, we will be like, internally, this will break it into sentences, and based on the sentences, it will classify. Okay. So let's see. Okay. So now if you see, the polarity has reduced. Okay. Subjectivity is similar. It's not changed a lot, but polarity has gone from 1 to 0.75. Okay. If you see the example, the reason why that has happened, this is a great tutorial on sentiment analysis. If you give this much, this gives you a polarity of 1. But if you add this information, I really enjoyed it and learned a lot. Okay. Over here, enjoyed is a kind of a positive word. Okay. And I would say if we use better algorithms, we'll definitely find this to be positive only. But in case of text block, the way text block calculates polarity is based on some fixed set of words. For example, text block is a purely heuristic based approach. Okay, it's one of the most simplest approaches and one of the basic approaches. It's not too powerful. Okay, so with text block, what happens is, okay, it has a list of predefined words. For example, good, best. It knows that these words have to be categorized as positive. Okay, and it knows that there are some words like worst and so on, which will be negative. And for a sentence, it checks that, hey, for this particular sentence, what are the positive words, what are the negative words, what is the count. Okay, and for every word it attaches some kind of score. Okay, for example, the score for very good will be very high, like it will try to give it a score of 1. But the score for, let's say, uh, okay, okay word, it will be kind of medium, like it will be zero point 0.5. Okay, so for every single word it tries to attach some kind of polarity or some kind of score. So for every sentence it will check how many words have a score which is, let's say, greater than zero point 0.5. Okay, which will say like it's tending towards positive. So for example, words like good, best, they may have, greater than zero point 0.5 polarities. Good may have zero point 0.7, best may have zero point 0.9. Similarly, it checks how many of them are equal to zero point 0.5. Okay, or let's not call it exactly equal, or let's call it approximately equal. Okay, it can be around zero point 0.5. So words like fine, okay, you know, these are neutral words which really don't convey a lot of meaning. Okay, for example, really, all these things are neutral. They are not specifically saying anything. I, it, anything like that. Okay, and similarly, you will have words which are negative words. Okay, so negative words like worst, bad, unhealthy, and so on. Good. So based on a single sentence, it will count how many positive are there, how many negative are there, and how many neutral are there. Right now, I'm not taking neutral, but let's say only positive and negative. And based on that, it will understand that, hey, if let's say there are 7 positive words, okay, which are having high positive scores, and there are 3 negative words which are having very low negative scores. Okay, for example, the second positive words have an average score of, let's say, 0.7, and the negative words have an average score of, let's say, 0.001. Okay, which is approximately 0 only. Okay, so now what it will try to do is it will try to find the balance. Okay, it will try to come up with something called as a like weighted polarity score, which is nothing but, since you have more words from positive domain, you would probably want that the final answer is given because of more of positive words, right? Because you have more positive words. So ideally, the positive words should have a more say in deciding the answer, right? Okay, just give me a moment. Yeah. So as I was saying that, mm, there are more positive words. So ideally, the final answer should be given more weightage based on positive. Okay. So how will this work? Is you calculate. Okay, let me clear this. Okay. So let's say there are positive words which are carrying different words. Okay. For example, let's say there are two positive words and they carry, let's say, zero point 0.7 and zero point 0.7, and let's keep it 0.8. Okay. Two words having zero point 0.7 and zero point 0.8 scores. Negative words having okay, let's say there are three negative words. Okay. 0.1, 0.05, and let's say 0.2. Okay. Now, how the final answer will be calculated? So we'll calculate this final score by taking a weighted average. In weighted average, we'll give weightage to the count of words, which is 2 and 3, right? So what will we say is, we'll take 0.7, okay, and we'll take 0.8, okay, and we'll take an average of them, okay. So over here, we are taking an average. So what is the average? So the average is 0.75. Cool. This is the first average. Similarly, we'll take an average of these three words: 0.1, 0.2, 0.3, which is how much? 0.35 divided by three words, right? That's what we have. And this becomes around roughly around 0.1. Okay, so I'm just taking a rough estimate, 0.1. Okay, so here we are saying two words are having average of 0.75, three words are having an average of 0.1. And now we simply can do one thing. Okay, so now we'll add this to get the final answer. 0.75 with a weightage of 2. So I'll multiply it with 2 plus zero point 0.1 with a weightage of 3. Okay, and in denominator, I'll add the weights, the 2 plus 3, which is 5. Okay, so your final answer becomes 1.5 plus zero point 0.3 divided by 5, which is how much? 1.8 divided by 5, which is roughly approximately equal to 3.6. Right? Oh, exactly equal to 3.6. I mean, it should have been roughly because this is a rough calculation. Okay, so over here, you are getting the final answer as 3.6. Okay, on top of this, at the end, only thing that will change is this will be normalized. Okay, it will be normalized by scaling between a value of 0 and 1. Okay, so text block internally has a normalized function. Okay, the normalized function you can see in the research paper of text block. But this function, the speciality of this function itself is to normalize the values. Okay, so what it will do is, if you end up with, let's say, a very high value, let's say a value like, oh, just a second, did I make any calculation mistakes? No, I think this is fine only, right? Huh. Okay, so now this normalized function, what it will do is, it will scale the values between 0 and 1. Sorry, not between 0 and 1, minus 1 and 1. Okay, so the more higher value you have, the more it will tend towards 1. Okay, similar to sigmoid function. Okay, it's not exactly sigmoid, but very similar to sigmoid. Okay, the more positive values you have, the more are the chances of seeing a value towards 1. Okay, so 3.6 will be somewhere around, you can assume, it's not too high. I won't say it's very high. So this will be a little toward, I would say, a little towards lower end. Okay, so this may be somewhat around, I don't know, maybe around 0.1, something around 0.1. Okay. So 0.1 implies that it's kind of a neutral statement. Okay, kind of a neutral statement. Okay, over here, if you remember in the starting, okay, because the scale is -1 to 1. Okay, so around 0 will be anything neutral. Okay, over here, the in starting, this values what we had given were in the range of, oh, okay, so over here we should have actually given some negative values because we took this on a scale of 0 to 1. Okay, so we should have actually given this as negative, okay, to explicitly say that this is a negative sentiment. But anyways, Now since we took the values itself on a scale of 0 to 1, this values are also on a scale of 0 to 1, then according to that, this 3.6 will be probably a little higher, okay, because we have not taken the negative calculations in place. So what will happen is this this 3.6 will be somewhat around, you can say, around zero point 0.3, okay, somewhat around 0.3 or 0.4, somewhat around that.
It is actually 0.36 only, MJ. 1.8 by 5.
Yeah, it will be less than 0.036. We take the minus value. Not 1.0.
No, 1.8 by 5 itself is 0.36.
Okay, are you
No,
saying
yeah,
over
that's
here?
Yeah.
Let's check it. Let's check it. Where is the mistake? I'm just trying to see where is the mistake. You have 0.75. You have this is fine, right? This is 1.5. You have point.
Yeah, everything is correct. 1.8 divided by 5 is nothing but 0.36.
Oh, okay. Sorry. 0.36. Yes, that's true. Okay. So over here, the reason why we are seeing this low value is because we have not scaled this. Okay, this should have been taken in negative. Because if we had taken this negative, we could have seen some negative values as well. Okay, and that is the reason why we are not able to see this. Just give me a moment. Okay, so over here, in our case, we are getting a score of 0.36, which is in our original data, we took values which were in scale of 0 to 1, right? We said 0 will tend towards negative, but this is not the reality. Like the value should have been between -1 to 1, and 1 will tend towards positive. Okay. So in this case, 0.36 will be again passed to your normalizer. Okay. And the normalizer will scale the value between -1 to 1 in ideal case. In our case, assume it will be between 0 to 1. It's already like very low, but this again would be scaled between -1 to 1. Whatever value you would have got, considering the original values were also between -1 and 1. Okay. And let's say the final answer that you get is something like 0.2. Okay. So now you know on a scale of -1 to 1, 0.2 is near 0, which means it's a neutral value. Okay, and that makes sense as well, because if you saw your original data, we had two positive words, okay, and three negative words. Two positive words which were extremely positive, three negative words which were extremely negative, okay, considering the scale was 0 to 1. Assuming that both of them should cancel out each other, right? That's what we'll assume in an ideal scenario, and this is what is going to happen. Okay, because the positive are two positive, negative are two negative. Count is exactly same. It may tend a little towards negative, but depends on the exact values. And this is why I'll probably assume the final answer may be neutral. Okay.
okay. I have a problem here.
Mm-hmm. Yeah.
So we are just counting the words, not the location. Point being, let me give you a very simple example of. Are you able to hear me now?
Yeah. Your voice is breaking a little. Can you repeat? You're saying you have count over here, then.
So, yeah, so where the words are located, point being, if the last sentence is a summary of all the above points,
Mm-hmm.
like overall it's a bad experience or overall it's a good experience, let's define the context. Just counting good, bad, some between it doesn't give you the complete picture.
So, as I said in the starting, right, text block is the most basic thing that you can do. Okay. In industry, we never use text block because definitely this is not the best approach. It's a heuristic approach, right? Where we have created rules based on words. Ideally, we should understand the context. And to understand the context, we'll have to go in prediction approaches. Okay, but this is not a prediction approach. This is a heuristic approach. You simply check the word: is it positive? Is it negative? You count the positive, negative words and take an answer. Right? That's the simplest thing that we can do. Okay. Is it okay?
Okay.
Yeah. Good. All right. So finally, you can see the final output, which is present over here. Okay. So this we have already seen it, and as I said, in this sentence over here, I really enjoyed it and learned a lot. There are high chances that enjoyed would have been thought of as a word. Okay. It would have not been thought of as a adjective, like something which has a high polarity attached to it. There may be few polarities attached to it, but maybe there are some other words which are fully neutral. Like, for example, I really, it, learned, a lot. All of them are neutral words. Okay. And because of neutral words, even though enjoyed would have been positive, all of them bring down the polarity. Okay. Because all of them are having score towards 0. And that is why polarity decreases to 0.75 from 1. Okay. Similarly, for subjective, it's slightly reduced. I won't say it has reduced a lot, because and it makes sense as well, right? I really enjoyed it and learned a lot. I would say this is not giving specific details, right? If you mentioned like I really enjoyed at that restaurant and learned a lot in maths, then you're giving specific details. Subjectivity is high. Here it's very simple. I enjoyed it, learned a lot. There is no specific details attached. Hi MJ, the voice seems to be very feeble. Can you be a little loud? Okay, let me check. Is others also finding my voice to be low, or is it fine? Can you
Uh,
mention it in the chat if the voice is properly audible? Fine for me. Okay. Others, are you able to hear me properly? Okay, okay. Fine only, right? Uh, okay. Shashwat, then probably it's a issue at your end if that's the case. Let me still check my settings. Okay, I've increased my audio. Hopefully, you would be able to hear better. Okay, let me know in case if you can hear me better. If not, you can try to rejoin. All right, let's proceed forward. So right now, what we saw is the simplest thing that we do. Okay, here text block doesn't take a lot of time. Okay, even if I go to any other article and you search for text block is it will give you the answer within few seconds. Okay, let's go to Kaggle. Right, you see this beginner level projects. Okay, now this is the interesting part. Here you see you are going to do some pre-processing as well. Right now, for the first sentence, we did not do pre-processing. And if you don't do pre-processing, the words get diluted. Okay, for example, this words like I, really, it, and learned, this will dilute your polarity. We don't want that. We should have handled it in the first case. Okay, that's one thing. And we'll talk about how we do all this kind of pre-processing, which we have been talking about. And in the final thing, as an output, I'll just show you. Okay, do you see this polarity minus point? It's minus only, right? Yeah, minus 0.46 and subjective is 0.6. Okay, so over here, this is talking about whether the final tweet is positive or negative. Okay, so let's see this example quickly. Okay, polarity, it simply means the emotion expressed. Emotions are related to the sentiment. That's fine, like joy, anger, and so on. The range of polarity is -1 to 1. We already know this. Subjectivity, it refers to some personal individual feelings, views, or belief. I'll say probably as specific as it is, the subjective will be higher. Okay. NLP steps done by text block for sentiment analysis. Sorry, is there any other question? Yes, it's better now. Yeah. So over here, it's conveying the same thing only. See, over here it's saying it conveys individual feelings, views, beliefs. It could be personal things as well. So for example, let's say if you are saying that, hey, he is happy, okay, why you are conveying the belief or the view as well? Because he has passed maths exam. Okay, this is very specific. Okay, you're giving the complete information with regarding the person. All right, now coming to the steps. So let's see what are the steps we are performing. Here we are doing lemmatization and stemming, lowercasing the words, cleaning the data. Lowercasing is generally done to ensure that everything is consistent. Okay, there are no words which are like in uppercase, there are no words in lowercase, so that text block. Okay, I think text block also it's fine, but even in other models that we'll see, we can keep the words in lowercase. In advanced machine learning models, it doesn't really matter whether you convert in lowercase or uppercase. But in text block, since it's a very heuristic based approach, it's better to keep everything consistent. Clean the data, remove the special characters, remove stop words, punctuation. All these are basic cleaning steps, right? We have already discussed why do we need to do this. Unwanted tokens, stop words. These are nothing but stop words like the, was, and so on. Tokenization is where you convert everything into words. Classification finally at the end. Okay, let's see this. You import all these are the basic packages. Install text block, which is fine. Import text block, which is fine. Pass the sentence, use the text block, get the sentiment. Okay, so just a second. Okay, I'm the worst programmer ever, right? As I said, worst would have a high negative polarity. Okay, and this is what is causing the sentence to be highly negative. Okay, in this case subjectivity is very high. Okay, the reason why subjectivity has been very high is because of programmer. Okay, here you are explicitly not giving any common reference. You are not saying like I'm the worst person, and you are saying your profession. You're explicitly saying that you are the worst programmer. You are being very specific, and that is the reason the subjectivity has been high. Had I said like I'm the worst man ever, subjective would change. Okay. Okay. Let's go to the tweet. Tweet. Okay, you can download this CSV file. If you import this CSV file, you'll see there are tweets and there are IDs. Simple. Okay. In tweets, we are applying text block on all set of tweets to get the answer. Right now, we are just taking one example because if you do pre-processing, the output that you'll get will be better. Okay. Without pre-processing, by the way, this output is not the best output. Okay. Let's see how we can make it more better by doing data cleaning. Okay. So what will we do is we'll use the text block function. And now we are just taking one single example, which is for tweet. Okay. So you're fetching from the DF, the tweet column. Okay. From the DF, you're fetching the tweet column. And in that, you are fetching the second index. Okay. So that will be 0, 1, 2. We love this. Okay. So you're fetching this tweet and you're trying to classify that. Okay. So you see this, we love this and blah, blah, blah. Sentiment and polarity is given. Okay. This is for one statement. You can do this for multiple statements, but where is the data cleaning? Oh, there is no data cleaning. Okay, so this person has not done the data cleaning. Okay. Oh, wait, text block will do some kind of pre-processing in the starting itself. That's true. Okay, you can check what kind of processing text block does. Okay, yes, it is doing. Okay, so if you see text block has some. Yeah, wait. Just give me some time. Text block, if you see over here, you can see that it extracts noun, it extracts a part of speech, it helps you in sentiment classification. This will learn later. Tokenization, okay, it's doing. So it's helping to convert the words into tokens. It's calculating the frequencies, which is not required right now. Parsing is also not required. Parsing is just your basic manipulation, like uh, handling all set of words, ensuring that words are, tokenized. In case if you have some commas, some full stops, all that will be taken care of. Ngraph, we already know. Word inflection, this is fine. Lemmatization, this is fine. Spelling correction, this is fine. Add new models of language through extensions, WordNet integration. Okay. So one inflection, WordNet, you'll see in the upcoming classes. So we won't go over there. But okay, it's doing basic pre-processing. Okay, I was of the opinion that this will not be doing any processing, but it has done some basic pre-processing. Then it's fine. Okay, if it has done basic pre-processing by itself, then we don't really have to worry about anything. Okay, cool. Let me share this link. And everyone says that in text block is the most simplest thing whenever you need fast outputs. Okay, but obviously it's not the best thing. We can definitely make things much more better. Okay, good. Any questions still here?
So MJ, the thing is, the words like the negative and positive words. So will it be like preloaded in that text block library?
Yes, it has already seen the corpus of words, like the dictionary of words from, let's say, if you're using English language, it knows what are the words in English. And for each of the words, it understands what kind of polarity they are associated with.
Okay. So
Yeah.
which like will there be any kind of grouping?
Grouping. Grouping as in group positive words like that.
So if the sentence is like meaning to having too much of negative words, so which
Mhm.
means they pick one, two, three words, and like based on that they will give the this one right polarity, right?
Yes, yes. As we discussed, the weighted average score will be taken into consideration. If you have more negative words, you will have more final say from negative words. Okay. So that's how the calculations will work. Same thing happens in your this thing as well, right? Linear regression,
Yeah.
right? If you don't standardize the weights which are like the features which are having very high values, right? They automatically get a more say in the final answer.
Yeah. Got it. Got it.
Yeah.
Thanks, MJ.
Yeah. Okay, I'll just show you one more notebook in which we'll manually do the pre-processing steps. Okay. Okay, just a second. Let me share the screen. Which screen am I sharing? have a look into this article. Okay. So here we are manually doing the pre-processing because they won't be using text block. Okay. Had they been using text block, they can still do some kind of pre-processing which text block is not doing. But generally, no one uses text block, as I said, in the industry because it's a very basic thing. Anyways, so over here they'll be doing pre-processing, making the data ready for the machine learning. Okay. As I said, you can build some advanced machine learning models. Right now, we have not discussed about the algorithms, so we won't be talking about how to build the models, but we'll definitely discuss about how to pre-process the data. Okay, so over here, by the way, do you guys know regex? Have you studied regex in Python?
Yeah, we know.
Oh, nice. Okay. So over here, let's say this is the data. Okay, the data is coming from customer support on Twitter. You can get the CSV file from Kaggle. Go to the input and download this. But anyways, we all we have to do is just understand first the logic. If you see in this data, you have multiple columns like tweet ID, author ID, inbound, created at, text, response tweet ID, and in response to tweet ID. Okay, so over here, if you go over here, let's just quickly see this. Okay, you can get the description. Unique ID is the unique ID for the tweet author, which is fine. Inbound is whether or not the tweet was sent, okay, to a company. So this is a support data. Okay, this is a customer support data, and this is just saying whether this tweet has been sent to that company or not. Okay, whether it was shared for whatever reason. Maybe it was flagged, maybe it was not flagged. In case if it was flagged, it will be sent. In case if it was not flagged, it won't be sent. Not only the flag is the reason, it could be any other reason. It could be maybe the tweet or something nice or something like that. Anything unique about that, it will be sent. When the tweet was created, which is explanatory, the text again is self-explanatory. The tweet that responded to this one, if any. So in case if anyone replied on top of this tweet, that's what it's saying. Which tweet ID has responded to it. And in final, this tweet was in response to. So basically, same thing, like the opposite of this. If this tweet, what you're analyzing, if that was in response to a another tweet, right? Whichever tweet this was in response to. Okay, so let's go back to the data. Okay, you can see a lot of details regarding the author and the text and all. The main goal for us is to handle the text values, okay? Because based on the text data, we want to classify. In some advanced machine learning models, we'll also discuss like using text, how we can add some more details, okay? For example, some more features. But right now we are focusing only on text. Okay, first thing, keep everything lowercasing. This is again like just to keep things consistent. So df text str.lower. This is, I hope everyone understands this. Str is your specific module, which will enable the lower function, which will help you in lowercasing the series. Okay, so now you can see the series has been converted to the lower section. Okay. Okay, next thing, removal of punctuation. So again, you can simply use regex for this. Just remove all the punctuations, whatever you have. What are they using? So they are dropping the text lower. They are using string dot punctuations, removing punctuations, text dot translate. Okay, so over here, here is where they are removing the punctuations. Okay, so what they are saying is you are pass. Okay, the column name was text, the original text. Okay, so in their example, they are not removing punctuations after applying the lower thing. Okay, probably because their end goal is only to show multiple types of pre-processing techniques. Okay, they are not trying to solve a problem. Okay, they are just trying to pre-process the data. So I think in the end, as you can see, like towards the right, they will probably not, they'll probably not build any machine learning model. Okay, so that's what I feel, and that is the reason why they are just showing different things. Because if they were not, ideally, you wouldn't have dropped this. You would have pre-processed this data itself. Okay, but anyways, if you want to process the punctuations, you can simply import this punctuation which contains the set of punctuation handling. Okay, so all the set of punctuations will be taken off. For example, comma, dollar, hashtag, special characters, at the rate, all of these things will taken care of. Okay, so simply just import this. You'll have punct to remove as the variable which you are storing. Over here, text.translate is a specific function in which you can change the words wherever you are finding this kind of words with whatever punctuations you have to remove. Okay, so for example, you pass the text in Lambda, this will go row by row. So let's say it will take the first row, it will apply the remove punctuation function. Okay, in that function, all it will see is wherever there's a space. Okay, because you have, oh, is there a space or is this empty? Okay, I guess this is empty. Okay, so wherever you are having every single word, empty means it will go for every single word. For every single word, it will check that, hey, whether that word has a punctuation. Punctuation means among this. In case if it has, replace it. Okay, replace it with what? Replace it with this, which is again blank word. Okay, nothing. Like just replace. I mean, this is same as saying it's deleted. Okay, so it'll check this word, deleted, this word, deleted, this word, deleted, and so on. Okay, I think we can make this optimized. Okay, I won't go into specifics of how we can make this more optimized, but right now all we will see is examples. Okay, stop words. Again, we can get this from a package called as NLTK's corpus. So I'll just show you the package. So NLTK is a very useful library, and this will use a lot of times in NLP. Okay, so NLTK has very useful features. Even to do any kind of basic pre-processing, we generally prefer NLTK only. Okay, even in like further in the notebook, you'll see NLTK is one library which has been used the multiple times. Okay, so this is the official documentation. You can go through the example usage if you want to use the API and all that. Okay, I won't go into the specifics of it right now, but okay. So over here, what we are doing is we are finding out the stop words in English language. So you're saying detect the language as English, and in the data which we have passed. Oh, so this is the entire English stop words. Okay, this is for entire stop words whichever are existing throughout. Okay, so simple. It's showing you these are the possible stop words that I know. I think it was earlier 15. Now they have updated to probably a little more. But you'll see all the list of stop words which are possible in English language. Okay. Now that you can see all the set of possible English words, all you'll do is you'll remove this from the data. That's it. Okay. So now you'll create the set of unique words whichever are there in this data. Okay. You see this function. So this is saying that for the word in the text, that means for word in your data, will split it and convert words into, I mean, sentences into word, right? For example, there is a man. Okay, if you use dot split on this, right, what will happen? There will get stored, is will get stored, a will get stored, and man will get stored. It's breaking the words. Okay, they all will get stored in a list. Okay, cool. That's how the output would look like. Okay, so basically you are breaking all the words and you are checking if the word, which means if the first word, like it will go one by one because you're using a for loop. If the word is not in stop words, then store the word in the list. As simple as that, right? So if there is not in the stop word, let's say there is in the stop word, okay? So what will happen? It will not get stored. Is also is in the stop words. It will not get stored. Is also a stop word. It will not get stored. Man is not a stop word. So this will get stored, right? So final list will only have man. Okay, and that's what it's saying. So you have the list of words which are not stop word. Let's say man, let's say man and assist. Okay, and let's say purpose. Okay, private. All these are non-stop words, right? And on top of this, you are combining them using join function, right? Join will convert the list into a string format. Okay, so whatever things are there, they will just get joined based on spaces. So man space assist space purpose space private, and this will be a string. Okay, so this is what you see over here as well. Like you see this text without punctuation is something which we had pre-processed in the last step, and on top of it you are doing the final pre-processing in which you are removing the stop words. So text without stop words. Okay, and as I said, the final answer will be in form of string, and this is the reason it's in the form of string. Okay, so the second column doesn't have punctuation, third column doesn't have punctuations, and doesn't have stop words as well. Okay, removal of frequent words. Over here, this I would say depends on the context. Okay, which problem statement you are trying to solve for. Right now, we won't discuss this because we have not discussed a specific use case where we have a need to remove the frequent words. Okay, so ideally, I would say this is a little based on your intuition. Okay, for example, words like, if you know, there are some words which are not stop words and they are very frequent in occurrence and they are not carrying any meaning. Unnecessary, they are just existing. For example, let's say the letter I. Let's say I is not a stop word. Okay, let's say the corpus is not taking it as a stop word. And I will occur a lot of times in your data, but I may not carry a lot of meaning, right? So we may want to remove this, right? So it depends a little on the context. You need to understand what kind of words are having high frequency and do we require. Okay, rare words, we had discussed this, right? As I said, if you are planning to create like a document term matrix, you can remove the rare words because rare words will cause sparse matrix, right? We don't want the rare words. Okay, so over here you can define what kind of rare words you have. Let's see how they are defining it. If word and not rare words, W for WWC in CNT dot most common. Where is CNT defined? Oh, here they have defined it. Counter CND dot most common 10 words. Okay, I, us, and all that. Okay, here they are basically taking from starting till minus n rare words minus 1, which is going to be the last 10 words, and taken in the negative order. Okay, which is fine. You get the rare words. Okay, so over here, what they are doing is they have used counter to get the frequencies. For every word, they are checking what is the frequency. Okay, simple words. So they are just breaking the sentence into words, and for every word, they will calculate what number of times the word is occurring. As simple as that. Okay, and now the counter stores the word and the frequency. Okay, and now the most common function of the counter will give you the top 10 words according to the frequency, as you can see. I 1437, us 752, 514, and so on. Okay, but this is the most common, which are the 10 most common words. But there are obviously other words which are not present here. Okay, so now if you see, if you wanted to handle the frequent words, you would handle the most common 10 words, right? Because they are the most common frequently occurring words, right? That's what you'll do. But in case of rare words, you'll do the opposite. Okay, you'll handle the most common words, but you will reverse the string. Okay, this is doing nothing, but it's actually reversing the string. So it's basically saying like, hey, we want the last 10 negative words. Okay, if you look at the slicing says start from it is ending at this is the step. So basically, you are saying you take the entire data, so it's like 0 till minus n rare words minus 1. Okay, which means minus 10 minus 1, which means minus 11. Okay, so 0 till minus 11, and the step size is minus 1. Okay, so what does that mean? Oh, just a second. Minus n rare minus 1. Minus 11. Okay, yeah, this is correct. So basically, you are starting from the 0th index and you're moving in a negative direction till the minus 11th index. Okay. So over here, you are using the, okay, notice this is not a list. Okay. This is a counter. Remember, count most common is a counter. It has values stored in form of counter values, right? Where you have the word and the frequencies. So you are saying, I want to get the last 10 words. Okay. This will go from 0 till minus 10. Okay. 0 till minus 10. Just a second. Okay. I think there should be 11 words. I don't know why they are saying there will be 10 words, because my calculation says there are 10 words, but 11 words. But anyways, it is going in the reverse direction. It's catching all the words, and whatever words are having the least frequency, they will be at the last 10. Okay. These are the last items that you have. Okay. And in that, you're picking the last 11 items. Okay. Which means you're picking up the last 11 items based on frequency, which means you're picking up the rare words, okay, which have the least frequency. Over here, this is the same function which we have seen from the stop word as well. This will just help you in creating the string, and you can just give the string. This string, what you see over here, this doesn't have the rare words. Okay, stemming is very simple. You import Potter stemmer. Potter stemmer is the library which helps you in doing the stemming. Okay, so Potter stepper is again a heuristic library. It has predefined rules regarding, first it identifies like using POS tag whether a word is noun, adjective, verb, or so on. If it sees that the word is a verb, it knows heuristically there are some rules, like for example, at the end, if es is there in the verb, change it to probably let's say e. Okay, something like this. For example, if it's goes, change it to go, like this. So it has some heuristic rules defined based on which it classifies. Okay, so just import from NLTK only stem.potter. This will help you in getting the library, which is not the library but specific module, Potter stemmer. Okay, there are multiple types of stemmer. Potter stemmer is the most simple one. Okay, it's the most basic stemmer. And industry people generally use Potter stemmer only because other things require a little more time to run. Okay, Potter stemmer doesn't take a lot of time. So people start with Potter stemmer, see the results. If they feel the results are not so good after applying the stemming, then they will think of using some advanced stemmer. Generally, people use basic stemmer, and when it comes to lemmatizer, they focus more on lemmatizer, right? As I told you before as well, generally lemmatizer will give you more proper words. Okay, cool. So over here, you have dropped the original columns because, as I said, this is just trying to show you different examples. You are calling the Potter stemmer class. You are storing it in a stemmer variable, and simple. Use the stemmer function from stemmer, like this is the method stemmer.stem, and just pre-process the word after going through the text. Okay, so you are going through each and every word and you are applying stemming on it. Okay, so it will check every word. It will check which one are the verbs, and on the verbs, it will apply stemming. Okay, so okay, here we can't see an example, but going forward, we'll probably see an example in which you can see the stemming applied. There is one more stemmer, which is snowball stemmer. This is a little advanced stemmer, but you can try with this as well. Okay. So if you see, right, walks and walking, they will be converted to walk. It's not necessary. Stemming will convert always to a proper word. It may not be a proper word as well. For example, console and consoling get converted to console, which is not a proper word. Right? Snowball stemmer, I think one advantage is with multiple languages, right? So it has support for multiple languages. Right now, we are not going to use Snowball. Lemmatization, we already have discussed about this. Lemmatization comes from WordNet. So WordNet is a form of lemmatizer. Okay. again, WordNet is a very powerful lematizer, I would say. Like, majority of the times you'll use WordNet only because WordNet, the accuracy with which it converts the word to their basic form is pretty high. Okay, so go to stem, import WordNet, call the WordNet, store it in a variable, simply use lematize, same as how did we did for stemming, and this will help you in converting the words to their regular forms. Okay, generally prefer using WordNet only. Okay, unless and until you don't see promising results, but most probably you'll see promising results only. Okay. Okay, one thing over here, in Lematizer, you have also the option to manually specify the POS tag, whether it's a verb, whether it's an adjective. For example, if you see this running did not get converted, okay, which actually is a good thing because it could be a good and bad thing both, depends on the other context of words, but at least it did not convert it into an improper word. Okay, so if it can shorten the word, that's good thing. But as long as it's not converting to anything like absolute, it's still better. So over here, we are explicitly saying that running is a verb. Okay. If we can specify that, then it's converting it to run. Okay, which is what we ideally expect. Okay. So with Lematizer, that's the only one thing where you can specify the POS tag. So POS tag we'll discuss later, like how to get this POS tag. There is again a library through which you can get the POS tag as well. And you can pass the POS tags for every word. Okay, look at this example. The sentence is print word is stripes. Okay, and now you are saying that, hey, lemma result for verb and the word stripes. Okay, so there are two contexts: stripes as a verb, stripes as a noun. Okay, in this example, stripes is a noun, right? It's a noun, it's not a verb. So over here, when stripes you are saying it's a noun, it's converting it to stripe. Where you are saying that stripe is a word, it's converting it to strip. Okay, stripe over here refers to the lines, right? The single line of stripe, which is a noun. Strip refers to a verb, right? Which means stripping. So over here, both are two different things. So you can notice how accurate and powerful this is. All you have to do is just specify the POS tags, and this gives you very promising results. Okay, so again, here you can,
MJ,
yeah.
do we have to specify it for every single word? How is it
Yes,
possible?
yes. So we'll use looping to specify it. There is one function through which what you can do is you use split function on your text data on your sentence. So let's say there is a party. You split it, store all the words like there is a, and let's say party. And for all set of words, we'll pass them through a library which is specifically for POS tag. Okay, we'll discuss about this, but this library will give you multiple attributes. Okay, there are multiple libraries that you can do it. You can do it using WordNet as well. Okay, and with every single word, you'll get to see whether it's a verb, whether it's a adjective, or so on. Right, so you'll get to see, let's say, there along with its what do you say, the part of speech, but there is a verb. Is let's say a conjunction, okay, and so on. Is let's say an article, party is like a noun, and so on. So now you know that, hey, which one are the verbs? I'll just put a filter to get the verbs, and only for the verbs I'll apply the lemma type. Right? This one way, like I can give verb separately, I can give noun separately. Okay, we can see this in the, I think, next example. They are also doing the same thing only.
Yeah, okay.
Okay, let's see. So they're importing WordNet. WordNet is nothing but the entire set of words which exist. WordNet lematizer, this is fine. Lematizer is being called. Okay, notice this. Over here, they have used NLTK corpus. Okay, NLTK corpus refers to entire set of all the functionalities of NLTK. Okay, that means everything. We have discussed this corpus, right? Corpus refers to union of everything. Okay, so you will have set of everything, and from that you are importing WordNet. Okay, they are using WordNet specifically for getting this part of speech. Okay, so now they are creating this map in which they are saying that key N represents the noun words, V represents the verb, J represents the adjective, R represents the adverbs, and so on. Okay, now it's very simple. All you'll do is you'll just check which ones are the nouns and you'll just put a filter for them. Okay, so from NLTK, okay, this is what I was saying. From NLTK, you can extract the POS tags. Okay, so you split all the sentences into words, apply the library, which is POS tag. So not the library is NLTK, but the function POS tag to get the part of speech. Okay, here you'll get all the part of speech. And once you have got all the part of speech, okay, what is this telling you? This is telling you that every word, for every word, whether it's a noun, whether it's an adverb, what is it? Okay, so once you know for every word, whether it's an adverb, whether it's a noun, all you'll do is you'll just map it with the WordNet map. Okay, cool. So what you'll do is I'll show you over here. So look at this. For word, comma, POS in POS tag text, right? As I told you that when you use the library, it will give you the word along with its POS tag, right? So that's what it's saying. For the word and its corresponding POS tag, okay? For all the possible words, simply do what? Lemmatize the word if the wordnet map dot get POS0 wordnet dot noun. Okay, so just a second, is it only lemmatizing the nouns? Get POS0 wordnet dot noun. Okay, so over here they have only lemmatized according to noun, but in my opinion, they should have lemmatized according to verb as well. At least noun and verb are something important. So I would ideally repeat this line one more time for verb. Okay, so I'll just tell you what they are doing. They're going checking the word and the POS, and for each of the word combination, they're going to lemmatize it. Okay, they'll see if that word is a noun or not. Okay, so basically they are seeing whether the POS of it, okay, they're fetching the POS of it. Okay, that's what they're doing. See, wordnet.map get POS. So over here, if you see in let's say whichever word that you're taking, okay, let me write it. So let's say the sentence is he likes to play cricket. What will happen? You will get individual words along with their part of speech, right? He is a noun, likes is a verb, to, let's call it for now preposition, play is a verb, cricket is a noun. Okay, so now with all of this attached POS, okay, this is the POS, okay, and these are the words. So what it's saying is you check every word, okay, that's what it's saying, and you check which ones are noun. Whichever you feel is a noun, you want to lemmatize it according to noun, because as I said, in lemmatize you need to pass the word along with how do you want to lemmatize it, right? And I mean, what is the POS for it? Okay, so here you are saying that hey, it's a noun because you are fetching only the nouns. Okay, so over here, he is a noun, cricket is a noun. Okay, and both of them will get reduced to their basic form. Okay, that's how things will change. But I would repeat this for verb as well. Okay, I would try to reduce likes and play as well. I think they might be doing it below. Let's check.
MJ,
Yeah.
lemmatizer is mainly used for verb only, right? Like, why do we use it for noun?
Yes, that's
How to
true.
reduce a noun?
Yeah, that's actually true. Lemmatizer is majorly used for verb. Noun is like a little special case. For example, there are some words which can act as verb as well, which can act as noun as well. Okay. For example, let's say cricket. Cricket is a noun, right? And it doesn't make sense to change cricket, right? Like if I changed cricket to crick, it doesn't really make sense because cricket can't be a verb, that's for sure. But if I take another example for let's say stripe only, right? You saw with stripe, it's behaving as both, right? Stripe could be a verb and it could lead to a noun as well. In this case, it's better to handle scenarios. For example, just to tell the machine learning in future the difference between both kind of stripes, like both of them are conveying the different meaning. You don't want machine learning to treat them as same, because if you don't explicitly say that this stripe is a noun and you say that this is a verb, what will happen? The sentence is, there are 20 stripes on zebra. Okay, let's say this is a sentence. Stripes is a noun. You don't tell, hey, the lemmatizer that this is a noun. Lemmatizer thinks this is a verb, and according to verb, it will reduce it to, let's say, strip, which is completely wrong, which is, mixing with any other verb which is related to stripping. So to ensure that this kind of nouns don't interfere the verbs, it's better to handle them separately. So if you tell that it's a noun, it is changing it to stripe. And now stripe will have a different representation, strip will have a different representation. And which is what we want, because this is a noun should be taken separately and this is a verb should be taken separately. So only for special cases like this, we generally handle the nouns.
Here we are doing lemmatizations after stemming, right? Is that okay?
No. So that again is something which we should be, which ideally I would take care of. I would generally say that first apply lemmatization and then only apply stem. Over here, I don't think so. They are trying to solve any end problem. They're just trying to showcase you multiple examples. But ideally, this is how you should do it.
Okay. So
Yeah.
fine. Can you just print this link also just for sake of it?
Yeah, I'll share it. Cool. Okay. So emojis, I won't go over here. Emojis is again like based on Unicode characters. You can simply go and use regex to remove it. But right now, let's not go to emojis, emoticon, and all this. Emoticons, this is not required. Emojis is not required. URLs, okay. URLs is removed through regex. How many of you know about re.compile? Have you used re.compile?
No.
Okay, okay, so re.compile, you can, whenever you don't remember any function, you can use simply regex 101.
Yeah, it is useful.
Yeah, right. So you can simply go over here, you can type whatever expression you want to convert. For example, like this expression. Just copy over here, paste it. Change it to Python. Write a string. Okay, you can write any string you want. Okay, but the main point is not with the string. I'm just trying to tell you what, if whenever you are not sure of any regex, just paste it over here and see the explanation. Okay, this will tell you what it's going to do. Okay, for example, re matches the characters. Re literally, okay, this is fine. Matches any character except this is fine. Okay, this is the main part. Compiler matches the characters. Compile literally, case sensitive. Okay, which means whatever pattern you are specifying over here, it will just try to match it. As simple as that, right? So over here, you just need to understand what is this pattern and it will try to match it. And the pattern is very simple. Okay, it doesn't take a lot of time to understand this. Even if you're not sure of any particular thing, you can simply scroll down and see the meaning of different characters. Okay, for example, HTTPS, which means the pattern should start with HTTPS. Okay, then let's say you're not sure of what is the meaning of question mark. Okay, so what it says, matches the previous token between 0 and 1 times as many as possible, giving back as needed. Okay, this simply means that it's simply checking if the previous character has occurred 0 or 1 times more. Okay, simple. So which means there should be a occurrence of HTTPS. After that, you have this character, right? What do you say? Full colon, and two slashes. Okay, which means again it's matching this exact character. Okay, so which means it's trying to match this kind of links. HTTPS, this, and let's say www. Actually, let's write wordnet.com. Just a second. Okay, let me copy this. Oh, sorry. I think over here it won't directly understand. Oh, would it understand the functions? Yeah, I think regex 101 does understand the functions. Okay, let's actually pass only the regex part. Okay, seems like there is some issue with this because we are definitely sure that this is working in Python, right? Because someone has used this. So I don't think so this is wrong, but I don't know why regex 101 is not identifying the pattern. Ideally, oh, wait. www.h2ai, okay, which is fine. h2.ai, this is also fine. Okay, this looks correct actually. It doesn't seem wrong to me. What is not matching?
Is it because you put the apostrophe before the HTTPS?
Oh yes, thanks. I didn't notice that. Okay, so over here, as you can clearly see that the pattern is for detecting any kind of links, right? So we are writing HTTPS, and then we are writing this main part, which should be present. Okay, it should be present. That's the only condition. Okay, and apart from this, like I won't go into very specific details regarding all these things, but it's very simple. All you need to know is just what is the meaning of every single thing. You can just hover over this as well, like you can see what exactly they mean, and you'll understand how they're detecting the links. Okay, so you write this regex. In nowadays, I think no one would ask you, even in interviews, no one asks you to write regex, and even in companies, no one actually remembers regex. Okay, personally, there are so many regex characters. The best thing you can do is simply use ChatGPT. Okay, use ChatGPT, get the regex pattern, save your time. Okay, anyways, let's conclude this. So it's basically handling the URLs, removing the URLs, and once you remove the URLs, you can clearly see this URL has been removed. This URL. Okay, what's the time? 9:22. Okay, let's just complete this. How much is left? Okay, HTML tag is something again we are not using right now unless until we do web scraping. Then only we'll require to use HTML tags. Otherwise, we won't require to use the HTML tags. Have you learned web scraping, by the way? Do you know what Beautiful Soup library? Have you studied web scraping?
No.
Okay. So Beautiful Soup library is one library which helps you do web scraping. Okay, through which you can extract information from any website. Okay, since websites are written in HTML language, the front end, the information that you extract is in form of HTML language. For example, let's say this may have been a website's code, okay, which is in HTML, and that's how you'll extract it. So now to get value out of it, you need to extract the HTML tags. Like you need to delete div, you need to delete h1, so that you can focus on the main part, which is S2, AutoML, right? The link, okay, and so on. Cool. I think this is fine. Spelling correction is something which we can see later. Okay, spelling correction will deal with it when we explicitly discuss about spelling correction models. Okay, let's wrap up. So if you see over here, I would say right now the best way to build projects is not to remember things. Okay, Because right now you have ChatGPT, so save your time. Okay, take advantage of AI. Even in companies, no one is asking you to remember things. Okay, that's for sure. With AI, even the interview pattern, I'm pretty sure will change. Okay, it's not going to be a case where you will be expected to remember syntax, which is what it was a few years back. After that, people said, okay, you can use Google, but try to come up with the code. And now what will happen is, this is like based on my opinion, but what I feel, what I have been noticing on how companies are working going forward, since this AI tools like Gemini, ChatGPT, and many other advanced tools which are going to come up with this, companies will focus on your understanding more, like whether you understand the concepts thoroughly, so that can you modify the existing functions. That's one thing. Like ChatGPT can't modify the existing functions. Okay, it can't modify the libraries, but can you understand things at such a deep level that you can modify things? And second, in interviews, I would expect that companies would not ask you, hey, can you tell us the exact code to do library? Okay, I mean, can you tell us the exact code to do stemming? No one is going to ask you for sure. Okay, no one has asked it in the past, except for a few companies, but majority of the times you won't be asked it. And right now, it doesn't even make sense because right now you have tools through which you can easily get the syntax. But yes, if they ask you, hey, can you tell us the pseudo logic, the like a skeleton code? We don't care about the syntax, but we care if you can tell us, explain the logic of how do you want to handle stop words. Then you should be able to write the pseudo logic. Tell them, I'll see the list of stop words. I'll remove the stop words by splitting the sentences into words. Check which ones are the stop words and just delete it from my list. As simple as that, right? So those kind of things can be expected. But don't expect companies to ask you all of these things in detail. And that is the reason you can always refer the internet for code. Okay.
Can you just share this link, this one, that's what we are doing?
Oh yes. I'll share this. Just a second. All right.
NJ,
Yeah.
in general, which package is usually used for NLP? Is it NLTK or spacing?
Yes. So both are very common packages, I would say. NLTK has a lot more support. It has so many functions which sometimes Spacey can't use. Spacey, I would say, is a little more specialized library. Some of the functions in NLTK are there which are not there in Spacey. But still, in future, we are going to discuss about both of them. But majority of times, I'll say like we'll be using NLTK only.
Yeah.
MJ, like, will you be getting any small assignments to do so that we have better understanding?
Yes. Maybe I can give you one assignment for today itself. So I want you guys to build a project on Twitter sentiment analysis. I want you to use text block. Okay. My assignments are focused on building stuff because I like people to build projects. Okay. This will help you learn a lot. Okay. So figure out by yourself. Okay. See if you can figure out by yourself how will you get Twitter data. First thing. On that Twitter data, do the sentiment analysis using text block. Okay. And try multiple iterations, see which one is like manually check which one is giving you decent results, okay, or the best results. Okay, you should be able to do this. We have seen text block, and Twitter data is something that you have to figure out on your own. Okay, so I'll see how many of you can figure that out. Get a bunch of data. I won't say like get entire Twitter data, that's not my expectation, but get at least a sample. Like even if you get 1,000 tweets, that's enough. Okay, so get this data. If you search online, you will see some Kaggle CSV which already have the data. I would say like keep that as a second preference. First preference, try to get the data by yourself. Try to extract the data by yourself. If you're unable to do it, then use the existing CSV files. But still, you should be able to do the text block implementation. Okay, one, you can either go with Twitter or you can go with IMDb. Okay, both are beginner level projects, something which you should be able to implement by now. Okay, any person who starts with like NLP starts with this basic level projects. Okay, so same thing, IMDb, you will have movie reviews. Get a sentiment of whether the movie reviews are positive or negative. Cool. Can I expect everyone to do this? Yes. On a final note, 1 or 0. How many of you think you would be able to do this? Can you write 1? Okay. Build this project won't take you, I mean, if you have understood all the things thoroughly, won't take you more than 2 hours. Especially like there's ChatGPT and all that. So take full advantage of ChatGPT. But definitely feel free to use Google as much as you want. Even in interviews, you're allowed to use ChatGPT, Google, and all that. So you don't really have to worry about syntaxes and all that. But ideally, I would expect if you're using everything, your results should be very good. Okay, good. All right, that's pretty much for today. Any other question? No? Okay, I'll see you then. Bye and have a good day.